All right, so thank you for the introduction. You have my coordinates here. So one of the things that is really always on top of my mind is how we develop better software and how do we deal with data that is produced by all of this software. And that naturally encroaches on the areas of both software architecture and data. And traditionally, there is a cultural gap between the two, and they need to merge. And in this talk, we are going to look into some of the opportunities and challenges to make this integration of the software and data side better, with the end result that we are able to consume the data that is created by our various platforms in a more effective way and basically bring in the agility in the organization that is processing data. So we are going to talk about, even though it is a talk about data, we are actually going to start with software and move from services to platforms, explore some areas of how data lakes become data swamps, the friction that exists in processing data in large organizations. And then we are going to look into the way how we introduce a proper relationship between software and data, and talk about the approach that is becoming known as the data mesh. So if you have been following software development in the last 15 years or so, you would not escape the notion of a domain-driven design. And domain-driven design is approach to development, which is based first on understanding the problem domain. So this is something that is known as ubiquitous language. So you build a model that is focusing on entities that exist in a problem domain. You look at their properties and relationships. So you end up with something that is like a logical or a conceptual model that describes this problem domain. And then in the development, you look into this problem domain. You look into what are the responsibilities. And then for your software components, you identify what is the key responsibility of that component. And this is how you organize your software components and services. And the question is, so where are you going to put the boundary around that? And this is something that is called a bounded context. Bounded context is self-enclosed area that is representing one important part of the business. For example, dealing with customer management would be one bounded context. Shopping would be another one, marketing a third one, and so on. So all of that leads with systems that are built more effectively. And more importantly, you have the great resemblance because your software structure now resembles the structure of your problem domain. Add some developments in technologies, and that leads us to such system being expressed as a collection of services. So you have services that are exposing the capabilities through interfaces. So these little symbols here indicate the interface that is offering functionality for other services to call. And this half circle is what the service can call by reaching out to other services and making calls there. So we are creating a set of services, and the dominant approach to that is known as the microservice architecture. In this microservice architecture, you have this clear notion of responsibilities, but then the question came, when we look at these services and groups of services, what is the mechanism that allows us to combine them in such a way that we provide more value to the end users and enable them to combine the capabilities more effectively? And that leads us to the concept of a platform. So the platform is a collection of services that work together and provide something useful for developers. The important rationale and thinking beyond that is that platforms are still providing the APIs that is called by clients. The API, we call it service provider interface, where the platform can reach out and call something from outside, and we keep the implementation hidden. There are three additional aspects around the platforms. One is we are paying attention about making easy connections. So we pay attention that the capabilities are exposed in a way where customers can easily understand what is being offered, so they can combine these services and build new products on top of that. The services that are exposed need to be attractive. So we are saying that certain platforms have gravity, and that is something that you see in commercial ecosystems, where you have the software as a service products. Those that provide exceptional value to their users have strong gravity, and then the users are gravitating towards them. And finally, the platforms need to provide a notion of flow, and that is the flow of exchanges of values. And basically, that indicates how easy it is to combine the services of the platform, to build new products, to create new experiences, something that is not possible by doing using services alone. So it's the further evolution of services, particularly going to larger systems. So here we have these platforms. And when you look into what is done in the platform, you will see that there is a set of components that are implementing the functionality of the platform. These components are hidden by users. Now, this is where you would normally, the literature on services and platform stops, but there is actually more to that. A very important part of the design is that platforms include also a variety of data stores. So these data stores are implementing things like transactional processing, things that are happening right now in the business are going to be reflected in these data stores. And if you go a little bit deeper, you'll find that modern platforms are not just going to use one database, but in fact, there is a whole range of things that can be used as their data stores. Operational stores, often relational databases handling transactions, but also when you need insights about things that happened in the past, for that you would like to have analytical store. And big data stores are very popular choice in this area. Another thing that is becoming very important is the processing of things that happen in real time. And for that, we need the processing of streams. Apache Kafka is one of the dominant examples of such stream processing. And if you look at this picture, we see that looking at the software side is not enough anymore. The data side of platforms can be significant and very complex, and it can be addressing operational, analytical, and the real-time workloads. And the question is, the platform is now using these services, but how is the whole enterprise going to benefit from that? And this is where we are coming to the idea of, let's collect the data from various sources in the enterprise, put them into one place, and this is where we can analyze it and offer it to consumers. And that leads to the notion of the data lake. Now, in the data lake approach, you have a situation where the platforms are exporting the data that have been created, and all of this data is supposed to go into the data lake. Here are some problems with this approach. It turns out that the idea of the data lake, where the systems will just dump their raw data into the data lake, and then the consumers would be able to apply transformations on read in order to extract the value from this data, that often degrades, particularly in large data lakes. And you end up with platforms that are producing some data, but they're also producing some data that have poor quality. As an example, imagine that you are dealing with customers. So you have the customer platform, and one of the things that this platform is doing, it is collecting the contact information of users. Now, not all users are going to give us their proper first and last name, but you may find entries where the customer is saying, this is the Mickey Mouse customer. Data like this is going to be collected and ends up in the data lake. So now your data lake has some data that is correct, and it has some data that is in the poor quality. The consumers of this would like to use this data in the data lake, but then they are finding lots of problems, and they are not happy with the solution. So what is going to happen in a scenario like this? Here we have with data lakes a very interesting situation that really degrades the capabilities of the data lake. We have a data friction, and this friction goes from the happy producers of data to unhappy consumers. So look at this. We have a data producer teams. These are the teams that are owning the platform. They do their processing, they collect the information, about this user. So Mickey Mouse is one of the entries. It gets dumped into the data lake. Now, the team that produced the data is happy. They are happy with their transactional processing and the data they create. They just send it over to the data lake. All the way here on the right, we have consumers of the data. So imagine analytics department, and they would like to analyze information about customers. They access the data, they find the Mickey Mouse, they are not happy. So they go and talk to the data lake team. So the data team, that is typically small, is far removed from the source of this poor data, yet they are asked to fix it. And this is why in organizations often see attempts to introduce the data quality, maybe third-party tools are being used and validated data sets trying to fix the problems. The big issue here is that now we have unhappy consumers of the data. We have the data team that is asked to resolve the problems which were not caused by them. And the big problem is that this data team is actually far removed from the source of data that actually produced this incorrect data. And that leads to great strain. And the big problem is that you cannot actually scale such a data team for very large domains. You know, if you have a small organization and your business does not change much, you could have a data team that is actually taking care of the data. But imagine a very large enterprise or enterprise that is acquiring companies that are in new businesses. The data team has no real chance of catching up with the subject matter knowledge for all of these domains in order to be able to do data work for the consumers. So what should we do? The first thing is we need to understand the split of data that exists in the domain. If you look in the platform, you are going to see that the operational part is handled and managed in the platform. And then their analytical data are dumped into the data lake. And conceptual problem here is that you have a split of data. Data that belongs to this domain is partly in the platform and partly in the data lake. So data that logically belongs together are in two very different places. So what we need to do, and this is the essence of this proposal, the notion of the software platform should not be limited to the software only, but it should also include the reasoning about data. Inside of the platforms, there will be data stores, there will be pipelines that are moving data from one place to the other, doing various transformations. And one of the key things is that besides the software interfaces, the platform should offer data interfaces. And these are the things through which the platform consumes the data from other sources. Let's say a Kafka stream, or if they need to ingest a file that contains additional information. And the critical thing here is that the platforms should often offer the notion of a data product. So besides the API, they will be treating the data they produce as a product. And that means that will be defined with the same care and rigor as they're defining their APIs. There will be data quality, there will be service level agreements, how this data is obtained. You have essentially a pride of ownership of the data that the platform is producing. And now, what is really fundamentally different in this approach is that the team that is producing this data and the team that is responsible for quality is the team that owns this domain. So they are right at the place where the data is produced. And if there are some issues that need to be fixed, they are the closest to the problem. So they are the best equipped to deal with it. So data product, important thing. One of the things that you can see here at the very bottom, there are the control APIs. They're used for monitoring, auditing, and other typical common data services. Now, we are saying that and this leads to accelerated insights. And why is that so? So imagine a hypothetical application where you have a customer platform that produces data about the customers. You have a platform that is keeping track of customer interactions, like what websites they visit, what ads they click on. And imagine if we would like to improve on the richness of the data. So we obtained a third-party data file that gives additional detail about the customers, maybe from some of the e-commerce stores and so on. And now the marketing platform can use the data produced by the customer platform, customer interactions, and these third-party files. They will be using this data, transform it to do the various processing, and they will create their data product, which is the marketing recommendations for individual users. Now, in this scenario, let's say there is a problem with the quality of data about the customers. The marketing team who is using the data can recognize, hey, we have a Mickey Mouse as a customer. This is not right. Let's go to the customer platform and talk directly with them. So what they can do, and this is a very, very concrete example. For example, at the ingestion form where the user is entering the data, you may do a little bit of checks. So you improve the data quality at the ingestion, as opposed to trying to fix it all the way there where it's used for analytics. So in this example, you have that the data lake team is completely skipped. They are not involved in dealing with wrong data, but what they will do, and we will see that in the next slides, is they will be providing the platform infrastructure that is allowing all of these capabilities. So one of the really important things, you can think that each of the platforms will be actually operating things that we see in the data lake. And when you look how is that typically applied, particularly in the cloud environments, you can say that all of these data products can actually reside in the same cloud. So physically, they are next to each other, but there is a logical separation and logical ownership where the platforms are owning and they are responsible for their data. So and that is quite interesting. So you have direct relationships between the consumers of data and the producers of data. Now, there are a couple of important things that we will need to address to make this work smoothly. So for this to work well, you need to have a couple of things. So inside the platform, you need to have the mechanisms for storing data, for processing data. You need to have mechanisms for data movement and so on. Now, the question is every platform going to invent these mechanisms on their own? And the answer is no, because that would not scale and you would quickly end up in a chaos. So what is essential for this is to have the infrastructure platform, and in fact, self-service data infrastructure platform. And this platform provides a variety of data capabilities as self-service interfaces. So there is a way to create file in object storage. There is a way to create, let's say, a MySQL or Oracle database as a service. You may have a variety of other databases, like a graph database. You have Kafka for messaging. So the user, for example, does not need to set up and maintain a Kafka cluster or install MySQL database. All of these will be provided by the infrastructure platform. And the user will be using the interface, which is saying, I would like to get a Kafka topic. I'm expecting that many messages per second of that size. So you help a little bit with the selection of the implementation. And all of these capabilities are provided by the data team. So the data team is dealing with infrastructure. They're exposing all the data infrastructure capabilities through a set of polished self-services. And when I say polished self-service, That means that you can go and use these capabilities without being forced to talk to anybody. And with that, the owners of the platforms can use these services, and then they can create, for example, ingestion from the file in object storage. They can put this data in, let's say, BigQuery, do some processing there, and then they may expose this data through either another file or possibly even through a streaming mechanism. And that will take care of the underlying technology. And you can imagine what you have in the public cloud. The services that public cloud is providing are giving you ability to use this infrastructure as a service. Now, so if you go to AWS or Google or Azure, you're going to find APIs that will allow you to do all of these things. The problem is you may still end up in a chaos. So what you need is a very strongly opinionated set of paths. How do you want things done in your organization? And this bottom layer is a set of services and capabilities that are established by the centralized data organization in the company. And there they are defining, how do you do security? How do you deal with privacy information? You have, for example, GDPR regulations, you have notice and consent, you have right to be forgotten, data subject rights, you have the governance for the privacy. You have various rules. How do you deal with data in the organization? All of these needs to be defined by the centralized organization, and they need to be put in place. So the platforms are using these capabilities, and they are in sync following the practices for the enterprise. Now, one of the critical elements is the data dictionary and the data catalog. They give you insight what is where in the enterprise. And they describe all the data stores with all the metadata, including what is a private, what is a sensitive information in these data sets, and so on. So you have three things. You have the set of rules, how to do things, that is set up by the centralized team. You have a self-service data infrastructure platform that builds on what is typically offered by public cloud, but it is hidden behind much nicer interfaces. And then finally, the platform owners are using these capabilities, and they are creating the data products that can be directly consumed by other platforms. And just as a note, the data product that is produced can be actually exposed in a polyglot fashion. So for some clients, it is better to expose it, let's say, as a file. For others, you may want to put it in a relational database. For the third, you may want to stream it as a Kafka stream. So you have a polyglot approach. Now, the ideas that we have here are not necessarily that new. So I would point you to some further reading to get deeper into this topic. Reading that I would particularly recommend is article that started this idea. And this is the article that is introducing the term data mesh. How to move beyond a monolithic data lake to a distributed data mesh. In this article, Jean-Marc Degani is starting from the deficiencies of conventional data lakes, and it is explaining the path that leads to the data product and the domain ownership of data that can be then rapidly combined, generating faster insights. Excellent article, highly recommended. But there are other things because you can look into that beyond the idea of data lake. And when you approach it from the side of platforms, it is worthwhile understanding what are the things that you need to introduce to go beyond services in order to create the ecosystems of software components that are give you agility in the whole business. And there is a great article from Harvard Business Review not focused on software, but it will give you great ideas how to transcend this just pure technical thinking and go into providing larger ecosystems of value that can support changing business needs. And one article that you would enjoy is the article Future of Data Engineering. One of the things that are really relevant and important for our thinking here is the step towards decentralized ownership of data, where going away from the centralized data lake principle, you have a number of stores that belong to different domains. And one thing that Chris addresses very well is the importance of automation. In order to get the agility, you want to have services that are providing the infrastructure, and you want to have the automation that make human labor and human activities not so important, and eventually you would like to eliminate that. And to give you an example of what that means, if I go back one slide. So imagine over here, you have the ingestion of some data. You may have some transformation of data that will be happening, and eventually you produce your data product. Now imagine that the way how you deal with that is you want to ingest a file, and then you're going to do the processing. You read through the records, you do some filtering and transformations. Imagine you put that in the relational store, you do some more transformations, and then you put it in another file. When I said automation, you can actually fully automate these things. So for example, in a system called Terraform, you have infrastructure as script. And that means that, for example, in public cloud, you can define that the Terraform is going to define the space that is a file in object storage in the cloud. Then the Terraform will have instruction to have a database created. Let's say you instantiate a MySQL database. It gets essentially installed for you at this point. And then you have another file that is the output. So this is the one part. And then you would have the additional steps that are defining your data pipeline, which may include, for example, Airflow, which is the orchestration framework for transformation of data. And with the Airflow, you would define what are the steps in processing. And with all of that, you can define all of the data infrastructure that is in the platform. You can define all the processing that is happening. You can define the containerized deployment of processing into the pipelines. So all of that is fully scriptable and automatable. So you want to be able to instantiate the whole platform, the data part with Terraform, and the software part above. Kubernetes would be almost the ideal choice for that. So you have fully scripted infrastructure, and that is enabling you to fully automate this and instantiate, for example, for testing. You can instantiate the whole thing from the beginning to the end, test it, and then you can throw it away. So you have a repeatable process. So to summarize, what we have is model in which the platforms logically own both operational and analytical data. So data is not split. They define the data product, which is a high quality definition of the data with their service level agreements. Platforms use the same infrastructure as data lake. So there is no shift there. What you already have as a data lake could be fully repurposed for that. And the platform teams use self-service data infrastructure platform. The question is this for everybody? And I would say it is not. For small teams and businesses that are not changing much, having a data team that fully understands the business, understands data quality and other issues, that might be the sweet spot. But in a very large enterprise that is growing, where the platforms are sizable and have rich software and data needs, where new business capabilities and new business offering is being introduced, this platform data looks very, very attractive and has ability to speed up things in the enterprise. And with that, I will finish my